Hello and welcome back. We've got another video today, and today we're continuing the second chapter of the book written by Matthew Walker, PhD, titled Why We Sleep: Unlocking the Power of Sleep and Dreams. Today we're going to be answering some important questions like how does your body know when to go to bed? Why do you get jet lag when you're in a new time zone? How can jet lag be overcome? Why does such acclimatization result in you experiencing even more jet lag when you get home? Why do some people tackle these problems using melatonin? Why does drinking coffee keep you awake and how? And the most important question, how can you tell if you're getting enough sleep? So sit back, grab a drink, and follow through till the end of the video. Hello and welcome to Pharm Glo's Clinic, your number one stop for everything on health and wellness. Make sure to subscribe to this channel and don't forget to click on the notification bell. Also, please give this video a big thumbs up, and if you ever have any concerns, questions, or opinions about the video, don't be shy. Just leave a comment down below. Now let's get into the video. Now, how does your body know when to go to bed? There are two main factors that determine when you want to sleep and when you want to be awake. The first factor is a signal that is transmitted from your brain's deep intrinsic 24-hour clock. This clock creates a cycle of day-night rhythm and causes you to feel sleepy or alert at the appropriate periods of day and night respectively. A chemical compound that builds up in your brain and causes sleep pressure is the second factor. You feel more sleepy the longer you've been awake because chemical sleep pressure builds up more and more with time. How awake and focused you are during the day when you'll feel weary and ready for bed at night. And, in part, how well you'll sleep are all determined by how these two aspects are balanced. The powerful structure behind the 24-hour rhythm in your brain is known as the circadian rhythm. In fact, this natural cycle is produced by every living thing on the planet with a lifespan of more than a few days. Every other part of your brain and every organ in your body receives a daily circadian rhythm signal from your brain's internal 24-hour clock. Your 24-hour rhythm helps to determine your sleep and wake cycle, and it also helps to regulate other rhythmic patterns. These include the timing of your eating and drinking habits, your emotions and moods, how much urine you pass, your body's temperature at its core, your metabolic rate, and the release of a variety of hormones. It's no accident that the possibility of breaking an Olympic record has been directly tied with a specific time of day being highest at the early afternoon human circadian rhythm peak. Because of the noticeable fluctuations in the vital metabolic, circulatory, hormonal, and thermoregulatory systems that this pacemaker regulates, even the timing of births and deaths exhibits circadian rhythmicity. Despite the fact that every person exhibits a constant 24-hour pattern, the peak and throw points vary noticeably from person to person. Some people experience their peaks of alertness in the morning and their throes of tiredness in the evening. These people are known as morning types, make up about 40% of the population. They are content to wake up around daybreak, prefer to do so, and perform at their best then. About 30% of people are evening sorts, or people who prefer to socialize after work. Naturally, they prefer to stay up late and wake up late the next morning, or even in the afternoon. Then the remaining 30% of people lie somewhere in between morning and evening types. Now let's move on to melatonin. Melatonin is a circulating messenger used by your suprachiasmatic nucleus to transmit the repeated signal of night and day to your brain and body. Melatonin also goes by various names. These include the vampire hormone and the hormone of darkness. Simply using melatonin is secreted at night, of course, not because it can give you fangs. The rise in melatonin starts shortly after dark and is controlled by the suprachiasmatic nucleus. Melatonin is released into the bloodstream by the pineal gland, which is located deep in the back of your brain. The job of the melatonin is basically to shout loudly to the brain and body that nighttime has come, just like a strong bullhorn. In this way, melatonin helps to regulate sleep time. Melatonin, however, does not have a lot of influence on the generation of sleep. This is one thing that a lot of people don't know, and that is why they try to use melatonin to induce sleep. Melatonin points the brain's sleep-generating areas to the starting point of bedtime. Melatonin does not take part in the actual sleep race. It merely serves as the official signal to start the event. These factors make melatonin ineffective as a standalone sleep aid, at least for healthy, non-jet-lagged people. As soon as sleep begins, melatonin levels gradually drop throughout the course of the night and into the following morning. A brake pedal is applied to the pineal gland at dawn as sunlight enters the brain through the eyes, stopping the release of melatonin. The body and brain are now alerted that sleep has come to an end and it is time to wake up by the absence of circulating melatonin. Let's move on to the next question. Why do you get jet lag when you go to a new time zone? Jet lag occurs because airplanes have made it possible to travel through time zones more quickly than our internal 24-hour clocks could ever keep up with or adjust to. Due to the fact that our internal clock still believes it to be evening, we experience fatigue and sleepiness during the day in a different time zone. It still hasn't caught up. As if that weren't awful enough, we frequently have trouble starting or staying asleep at night since our internal clock now thinks it's still midday. Fortunately, your brain and body will not stay in this limb forever. You will eventually acclimatize to the time zone of the new place by the help of the rising and setting of the sun. However, this can be a very slow process. For every day you are in a different time zone, your suprachiasmatic nucleus can only readjust by about 1 hour, so it might take a couple of days to fully adjust. You can see why certain people frequently experience jet lag. Now, a lot of people, especially airline pilots and cabin workers, would prefer to minimize such suffering in light of these negative impacts. They frequently decide to use melatonin supplements in an effort to address the issue. Can melatonin pills help cure jet lag? Melatonin has been extensively researched as a sleep aid and jet lag therapy, and it is now a widely recognized component of successful jet lag treatment. Recent studies appear to support the idea that melatonin promotes sleep during hours when you wouldn't typically be sleeping, which makes it useful for people who suffer from jet lag. Because melatonin is perceived by your body as a signal of darkness, it typically has the opposite impact of bright light. It's crucial to take melatonin at the right moment. Take melatonin at local bedtime every night until you've gotten used to local time, and if you're trying to adjust your body clock to an earlier time, such as after flying east. Now, like we've discussed earlier, melatonin will not induce sleep. It will only trick your brain and body into thinking that it is nighttime. It might still be a struggle to sleep at this point, but it greatly increases the likelihood of sleeping. Why does taking caffeine keep you awake, and how? To answer this question, we have to quickly look at something called adenosine. Adenosine is a chemical found in human cells that induces this desire to sleep in the brain. Caffeine works by successfully battling with adenosine for the privilege of latching on to the adenosine welcome receptors in the brain. Once these receptors are occupied by caffeine, it does not excite them like adenosine does, therefore taking away the desire to sleep. Caffeine acts as a masking agent by blocking and effectively deactivating the receptors. It's the same as covering your ears with your hands to block sound. Caffeine prevents the brain from receiving the drowsiness signal that adenosine would normally transmit by hijacking and occupying these receptors. The end result is that coffee deceives you into thinking you are awake and attentive even though high amounts of adenosine would normally tempt you to sleep. Now, caffeine has an average half-life of 5 to 7 hours and can therefore disrupt your sleep pattern, so it's advisable to stay off it unless absolutely necessary. Coffee can help you stay awake late at night, but you should be aware that when your liver removes the caffeine from your system, you may experience an unpleasant side effect called a caffeine crash. Your energy levels quickly drain and you feel extremely sleepy once more, and that makes it challenging for you to function and concentrate. And now the most important question, how can you tell if you're getting enough sleep? While a clinical sleep examination is necessary to fully address this issue, following a simple rule of thumb can also give you a straightforward answer. Do you always feel sleepy around 10 or 11 a.m.? If yes, then you most likely aren't getting enough sleep, either in terms of amount or quality. The second question is, can you function well before noon without caffeine? If the answer is no, then you're most likely self-medicating your state of chronic sleep deprivation. And we've come to the end of today's video. Do all you can to get the appropriate amount of sleep, and if you give your body the adequate amount of sleep, it will give you back the adequate amount of energy and alertness you need when you wake up. Always remember this. What do you think about this video? Let us know down in the comments section.